In this video, let us solve few more problems related to trigonometric functions. So let us address the below problem. So we have been given a right angle triangle ABC, which is right angled at B. So let us draw the right angle triangle. So the information given to us is it is right angled at B. So this can be A and this can be C. Now AB is 24 and BC is 7. So we don't know what the hypotenuse is. We have to find that out. And also we have to find sine A cos A and sine C cos C. So we have to find sine values from this position as well as the angle C. So let's start with finding out the Pythagoras theorem, like the hypotenuse using Pythagoras theorem. So in this case, AC is nothing but square root of 24 square plus 7 square, which is 576 plus 49, which is square root of 625. So AC is equal to 25. So this will be 25 hypotenuse. Let me fix this. Okay, now we know the value of AC. Now we have to find sine A and cos A. So sine A is opposite by hypotenuse. So when we are standing here, the opposite side would be BC. So that would be 7 by 25, and cos A would be adjacent. So 24 by 25. Adjacent by hypotenuse. Now the second set of values we have to find is sine C. So when we are standing here, the opposite side would be AB, which is nothing but 24 by 25, and cos C would be adjacent. So here it would be BC, which is 7 by 25, like adjacent by hypotenuse. So this is how we can find the sine and cos values at different positions in a triangle. Now let's address the next problem. So we have been given a right angle triangle which has the hypotenuse of value 13 and one of the sides is 12. We have to find tan P minus cot R. Now before we solve, let's apply the Pythagoras theorem and find the value of QR. So QR would be square root of 13 square minus 12 square. So this would be 169 minus 144. This would be square root of 25. So the value of QR is 5. Now we know all the three sides of the triangle. It would be very easy for us to find the tan and cotangent values. So let's try the first one, tan P. So tan P is nothing but opposite by adjacent. So in this case, if we are at point P, opposite would be QR, which is 5 by adjacent would be 12. Now cot R is nothing but 1 by tan R. So let's write it as 1 by, if we are at point R and look at the opposite direction, so QP would be the opposite side. So 12 divided by QR would be the adjacent side, 12 by 5. And when we solve the inverse, it would be 5 by 12. So now when we solve for tan P minus cot R, that would be 5 by 12 minus 5 by 12. So the value would be 0. So this is how we can solve the inverse trigonometric functions like cosecant, secant, and cotangent.